Hello guys, Gennady here. Welcome back to ABPKit Dev Series, a series in which I share how ABPKit is developed. Today we will continue in exploring how we can implement one of the core functionality of ABPKit, that is loading a particular filter list. In previous episode we have translated those requirements into some domain code that describes how a filter list can be loaded. We have ended up with this protocol that describes how a filter list can be loaded for a particular source, and we have here the whole structure that defines the different sources that we have. Behind the scenes, I did some housekeeping and moving the code on different files. As you can see, we have here the filter list loader files and filter list source files, so we can have those separated nicely. So let's dive straight in what we'll do today. In previous episode, as you recall, I've said that we don't yet know how we will implement the logic of loading the particular filter list. We knew what we wanted to achieve, so we translated this requirement, what we want to achieve into protocols and the filter list source, basically to act as a skeleton of further implementations. And today we will start with some actual logic and behavior on how actually the filter list is loaded. We will guide us through test-driven development cycle. So basically, unit tests will help us in designing our components. So let's dive straight in and see where we'll end up to. And let's create a file in our test target, and let's call it filter list loader tests for the moment. It's a very generic name, but I'm not very sure with which component we'll end up with. So let's call it right now like this, and then we will see which component we'll create from our tests. We don't need an Objective-C header, no thanks. So let's import XC test so we can make use of all of the beautiful functionality of unit tests in Xcode. Let's define our test class filter list loader test that needs to inherit from XC test case so our tests can run. Further, in actual TD cycle, we actually need to create some test function first and then some assertion so we can drive our component from there. But right now we actually know what we want to do. We know that we have the protocol filter list loader protocol, and we want to have some component that implements this protocol, and then we will need to decide how it internals looks like, but not necessarily the actual component. Let's define this component and let's call it filter list loader implementation, because as I said, we don't know yet what this will actually do. And we need to implement the filter list loader protocol, but we don't yet have access to it. So how can we solve it? Well, let's import ABPKitDev. Did this help? Well, not quite. And this is because our filter list loader protocol is internal. It's not accessible to the public, so it's kind of shy to the public right now. So what can we do? We either use testable import, so we can force filter list loader protocol to come to light, either it wants or not. And this is a trick in unit tests, so we can test our actual internal components, not public. Or we can make our filter list loader public, so we can access it directly in unit tests without having this testable identifier. So which one is the best? As we can see here, the import ABPKitDev, it's kind of the same, and well, actually it's the same as it will be used by the clients. Clients will import ABPKit and then use it in their app or whatever framework. So it actually describes very well how the clients will use this. But we need to think of, is filter list loader a public API in this case? And if we look at this, yes, it would be actually one of the primary points with, or let's say component with which the client will interact. So it makes sense for this to be public. And with this in mind, we can use this trick of having the testable or not to actually have a point in thinking, is this a public API or not? Of course, it's not a irreversible decision, not that we cannot change through internal or public at any moment, but it's actually good that we have, let's say, a test target where we can think of what is public or not, and this is actually forced by Xcode. So right now I'm thinking that it's a good call to go with making filter list loader public and everything related to it, because it's actually what will client interact with. So let's make here everything public. We need this to be public, and also filter list sources, everything. Yeah, we kind of have a lot of sources, but 2 more to go, and we are done. Let's build everything built successfully. So right now we should be good here. Let's build. Yes, we need to conform to load protocol. So we have added here the load, and let's build yet again, and we have built it successfully. So we have defined this class, and this was very easy because we kind of knew that we want to do this, but the actual point where we want to think more of is what goes here, how we handle the actual loading of a particular filter list source, and let test help us. But before going into this, let's see our structure of filter list source. We have here the protocol that filter list loader that actually uses a filter list source, and then it splits in bundle filter list source and remote filter list source. And as we can see here, those split nicely, completely separated, because a remote ABP filter list source is completely separated from bundle filter list source, and well, kind of the same for bundle filter list source and remote filter list source. And here we kind of have two options of decide where we want to go. We either have those two glued together, and we ignore that we have bundle filter list source and remote filter list source, and basically we work directly with filter list source, which then translates into having everything in same component or same file that will load the filter list source. Like there is no strict or concrete separation between bundle and remote. And the second options, of course, is to separate completely everything relating to remote from bundled filter list source. And to me, it looks a way better option. I don't see any logical reason to have bundle filter list loading logic in the same component that handles the remote loading logic, because those are separate concerns, separate components. And maybe if we think of what if we want to provide the functionality to clients only to load the remote filter list source or only bundle filter list source. This the separation looks quite promising also in another ways, that maybe we can provide an API that loads only from remote and not from bundle filter list source. Well, let's see. This is for the future to think of. So let's start with some actual test. Let's write test. We want to test the load in which scenario? Well, as we see, so we have bundle filter list source on a remote filter list source. Let's start with bundle source. So the load in the case of bundle source, what should we do? Well, we should load from bundle. And right now it's called load from bundle, but I don't think that we will actually here access the bundle and load from the bundle. But we should see. Let's create our system under test, which is this class. And what we will want? We'll want to load and to load for bundle source. And let's create one right now, ABP with A, and let it be Russian. Why not? Let's have here bundle source. Do we care about completion? I don't think yet, but we shall see. Because we want actually to assert here that we request the load for the bundle source. So here most probably we'll have like this bundle source and we want to compare against that, we load against it. So we have to decide in this component, do we have all of the logic here loading from the bundle or not? And kind of the same for remote. And previously we've said that it will be more nicely to separate those flows in a completely separate component. So maybe this filter list loader will shape up to being just a strategy. So we will actually only decide which path of execution to take. But let's see. So I think that we will need some collaborator that will load for us the filter list from the bundle. So we will not get entangled with it in this component. And let's call it bundle filter list loader. Why not? Because we have already filter list loader that loads for a filter list source, and for a bundle filter list loader we can have bundle filter list loader. Yeah, it seems good. So yeah, let's create this one here, bundle filter list loader. Let's instantiate it, and what we will want to assert on it? Well, we want to assert that requests, let's say request to load is equal to bundle source. And if I have multiple, let's say that we actually have here an array. Let's define it here. Requests. So bundle filter list source. We should build almost, because our bundle filter list source is not equatable, and yeah, why not? It makes more sense to have this equatable than not, because maybe clients will also want to compare, to be able to compare two sources. So let's make it fast. Everything should be equatable, so we can compare sources to sources. Good. Let's run again, and yeah, everything went well, besides the fact that we are failing, but actually that's good. That says to us that we have expected to make a request of loading the bundle filter list source, but actually there is nothing. So we actually need to tie together bundle filter list loader with filter list loader implementation. And here we either have a concrete instantiation here in place, let's say bundled filter list loader, and we can have it here. And why not? We actually do this a lot in our day-to-day programming, iOS code base and so on, that we instantiate component fairly easily here and there directly. But actually tests can help us and see that no, this is actually a problem. And why is this a problem? It's a problem because we will want in our test to actually test against our mock class, not against concrete implementation. Because we have here this request property that Of course, it does not make sense to be in any production component, because it's only for testing purposes. And it will be actually nice to be able to inject in this class different components that has different behavior. So let's actually change it to be injected through initializer, and let's put it here. Bundle filter list loader, and of course we should have here self. Here we should add this, and we should be build successfully, everything good. But of course we do not forward the logic. We actually don't call anything on bundle filter list loader. Let's fix this. We switch on source, and if it's a bundled source, we should do something. It's default. Well, it should be remote, but right now we don't bother with remote. We are looking on the bundle filter list loader part. So we have bundle filter list loader, and we will need to actually request a load. So in this way we shape the actual API that will go into the production component. Let's say here source, and it should be bundle filter list source. And as you can see, this kind of shapes to be the same API as for filter list loader, that loads for a filter list source and then it's complete, and then it completes. And for bundle filter list source, it kind of will be the same, but let's see. So load for source, and we should forward here bundle source, and here we should add these two requests. We have added it, all good. Let's build, and everything goes well. This test passed. We have actually asserted that we request the load for the correct source, and that we are not doing any magic, let's say changing this source or something like this. How we have defined it here, it the same breaches bundle filter list loader. So so far so good. Let's move forward, and let's see what our next test will look like. Bundled source, and well, we have asserted that we request for the correct source. Maybe we will want to do we want to test multiple requests? Those are in order. Well, I guess we'll see further down the line. But for the moment, what comes to my mind is to test that when the bundle filter list loader completes loading, that we forward this result up to the chain. And let's say that failed to load from bundle completes with error. This is what we want to achieve. So we will need everything from here, and we will need actually to assert here. And let's say we have the result here, and let's first create our assertion. Let's switch of our result, and if it's success, then we should fail, because we expected load to fail. And in case of failure, actually I don't think we care about error. We just care that it fails, because from the bundle it can be any error, and actually it's not that very important for the moment. I'm thinking of handling that we throw the specific error. We just want it to fail. Let's break it here, and we actually need an expectation. expectation. Let's make wait for load. Here we should fulfill our expectation. Why Xcode is not helping me? Let's name it load expectation, because it conflicts with the name of expectation. And let's wait for our load expectation. Good. So far so good. Let's run, and we should fail. With expectations here freshly introduced, we can test kind of asynchronous API that we have with the completion, that by its nature it can complete, or maybe it wouldn't complete at all, or it will complete some later in time, not right here right now. So expectations are a good tool to use to test some asynchronous calls or through callbacks, something like this. Let's see what we'll have to do here. Well, we have to have a completion, and with TDD cycle here, we kind of, let's say, first will be to add the error case, and then as you can imagine, further we'll go with the success. But right now I think it's fairly clear that in bundle filter list loader we will have the same completion as for the filter list loader that we load for the filter list, and I don't see right now the point of going in those micro steps. We can take a leap of faith, maybe so to say, and go a little bit faster. So we can grab this from here, put it here, and we can have also the completion brought from here. Okay, so we can do here just like this. As I said, in some normal or usual TDD cycle one, we don't yet know what our API looks like. Maybe here we will just complete with error and then with success, so to say that moving it in micro steps. But right now it's kind of very clear to have the straight away the completion. And this is one of the cases with TDD, that when you are not aware what you want to do, or you are in the wild, so to say, and you should move with micro steps. So because we are not very aware of what are all the implications, maybe what we want to achieve, so we move in micro steps just to not break anything. But when we are fairly confident and it's kind of here into your face what needs to be done, there is no necessarily a big point in keeping moving in small steps, because it will tend to slow you. So we can move straight away and put here what asks to be put in here, as in this case with this completion. So we have added here the completion, and we blinked it, and let's see if we build. Yes, we build it, but still we fail, because here we don't complete with anything. And from there we have two options. One is to stub our result, and it will be something like this. Let's say stub the response, stub result better, and it's kind of a load result, and let's make it optional to say. And once we reach here, we can have completion with stub result and whatever, something like this. This will be an option, so our API will respond straight away. And if it's the case with this, I think we don't even need the expectation, because we will complete straight away, and it's not asynchronous. But actually, it will be better to test for some asynchronous calls, to see that we call a little bit later the completion. Let's for a nanoseconds, for the smallest interval, so we can test a little bit this asynchronous part. So how can we do this? Well, with this we actually need to capture the completion and then call it later to complete, and we can do this very easily and nicely here in test. And well, let's actually do it. Let's say private var let's captured loads, something like this. Not my best naming for sure, but yeah, it's good. We capture the source, and then we also capture the completion. Good, and we can have it like this. Yes, we need this, and we can append the source and the completion. And requests will change to something like this. We will have to extract the sources from captured loads, not like this. What I'm doing, it needs to be like this. Yes, so we don't break any of our previous tests. The first test should still pass, of course. If it's not failing, why there is an S, I don't know. This should be good because we didn't break any of our API tests. Of course, we have here the load, and we need to have an API to complete the loading. And let's have here the function complete load with some result. Let's say result, we have load result. And since we have an array, maybe we have multiple requests, let's have it at some index. Good, so then we can go through our captured load at some particular index and call our completion with this result. Good, let's see how it will look in our test. So we have here the load, and as I said, we've stubbed result. This will complete like straight away, because in the completion this closure will be called straight away. But with our captured style, and then that we call it later, we kind of simulate this asynchronous behavior. So as you can see, we have bundle, filter list, loader, and then we call complete. A little bit later, the next line of code, but it's still a little bit later. And actually, it's actually very nice that we can test this asynchronous behavior with let's say in microseconds. That it doesn't need to take seconds to test. So we need to have the result. What result here we have? We'll have the failure, and at index, well, right now we have only 1, so I don't have here 0. So we don't need to pass it. Here we'll need to have an error, and let's create a test error, and with code 1 and whatever, no user info. Let's remove this. Good, we have completed it. We should run, and everything went well. Let's see. Yes, here, if we break something, here we have it with the completion, and we don't further it. Let's say we don't pass it here, or that we have it something like this. Let's actually test for this, and we have our completion, And we do here some stuff that we complete with success, blah, whatever. And we should fail because we have completed with success. So basically, we have tested that we don't do anything in our component, but rather we just forward the result of loading from the bundles up to the chain. So we don't do anything hidden here. So let's have here the completion. So everything is good. So with this in mind, that we have implemented the complete with error, we can go straight away and implement complete with success, and it will be kind of fast. Completes with filter list, and as you can imagine, if this is failure, we will actually fail that we expected to succeed. And in case of the success, let's say here we'll have the result and we'll have the loaded filter list, and we will need to compare our filter list to some expected filter list. Good, let's create our expected, or actually let's call it bundle filter list because it's what's in bundle filter list. And let's create our filter list with some dummy rule, let's say, because we don't care of the actual structure of filter list. Right now for us it's just a plain string, and we expect this to be equal. If not, we have expected to load the bundled filter list, but we have loaded instead the filter list, not this one but this one. Good, we have let's say this setup, we have the expectation, and here we don't complete with failure anymore, but we complete with success bundled filter list. So we load for the bundle, we complete with bundle filter list, and we expect that this bundle filter list is forwarded, and we should build successfully. So we can remove this because we kind of know what will go further. We'll load from the remote source, and we'll need to see what goes here, but most probably it will be kind of the same as we have with bundle filter list load. So I think we can conclude here for bundle source, and in next episode we'll go with loading from remote source, and as you can imagine it will be kind of the same for the bundle filter list loader, but at the same time we will have to do some cleanup in our tests, because as we can see here and here there is a lot of duplicated code, and also the same, like initializing our system under test, and also here for bundle source we need to change this, have some function that tells that this is not to be true only for this particular source. It can be true for any bundle filter list source. So we'll do some actual refactoring to improve how our tests read, and at the same time we will complete this component, and we'll add a loading from remote, and this most probably will go to be named something like strategy, because it looks to be like a filter list loader strategy. You know, the filter list loader strategy design pattern that at the prime time decide which path of execution to take. Right now let's move it back so our tests don't break. So most probably we'll create also the remote filter list loader, and then from those mock classes we will extract our I think protocols. So basically we will have filter list loader protocol as we have it here, and then most probably we will create also a bundle filter list loader protocol that will know how to load a bundle filter list source, and then a remote filter list loader protocol that will know, or actually will describe how to load a remote filter list source. And here in our strategy we will only decide in which way to go. So it's kind of looking to having how to load from bundle and how to load from remote separately, and then this component that we have started to implement today, actually what it does, it's only gluing together those two paths of execution. So yeah, that's pretty much it. We kind of kick-started the implementation, the actual implementation, and it's looking promising. So see you in the next episode. Bye bye.